All right, Algebra 1 students, we're going to look at Unit 2, Lesson 16, Solving Systems by Elimination, Part 3. So this is our last lesson focusing on elimination. We have two lesson goals. They're kind of longer worded, so if you need to, pause as I go through them to get it written down. I can solve systems of equations by multiplying each side of one or both equations by a factor, then adding or subtracting the equations to eliminate a variable. What this is saying is, if adding and subtracting the equations as they are doesn't eliminate a variable, we're allowed to use multiplication by a factor to create equations that will eliminate. I understand that multiplying each side of an equation by a factor creates an equivalent equation whose graph and solutions are the same as that of the original equation. If I take an equation and I multiply both sides of it by a factor, that equation stays the same, which then allows me to use elimination to get rid of a variable. So in doing this, I can use a modified equation or a equivalent equation to do the work. So we have our same four focus words, and then we have a new one here. Solution to a system of equations. It's just where the lines cross, essentially, where our graphs are intersecting, what that shared solution is. Substitution, taking an expression, plugging it into an equation so that it is then simpler to solve. System of equations, remember that is any two or more equations of a situation that represent the constraints of that situation. Elimination is the ability to add or subtract two equations to eliminate, get rid of a variable. Equivalent systems. Two systems are equivalent if they share the exact same solution set. So this is the idea that if I multiply an equation by a number, I get an equivalent equation. And then that equivalent equation with the other equation creates an equivalent system that will still give us the same solution. All right, so we have a system here to work with, and we're going to call the top equation equation A, and the bottom equation equation B. Please write this one down. We're going to then do some work to equation A, and then we're going to just look at it and see what that work does to the graphs. So the first thing I need to do is write this down, and then on some graphing technology, graph this system like we've done in the past. So use Desmos, that would be the easiest thing. Once you have that, identify the coordinates of the solution. So where do they cross? What is their shared solution? All right, then you're going to write a few equations that are equivalent to equation A. What I want you to do is multiply all of equation A, the left side and the right side, by the number 2. And write that down as equation A1. Then you're going to go back to the original and multiply all of it by -5. So you're going to take all of this multiplied by -5 to get equation A2. And then you're going to do the same thing with -1 to equation A to get equation A3. What I'd like you to do for part 3 is graph equation A1, A2, and A3 on your technology with the original two graphs. Once you have those 5 graphs on your technology, give me 2 observations about the graphs. What do you notice from these graphs? Okay? That information, all that work and your understanding of these 2 graphs, bring to class tomorrow, and then that's going to start our discussion as to where we go from here with elimination. Thanks.